Okay, today we're going to do the power rule. So the power rule is one of the most important things in calculus. It's something that a lot of people will remember if they've taken calculus because it's really important and we use it a lot. So there's a definition of a limit where we have the limit as x approaches 0 of f of x plus h minus f of x over x minus h. So this is something in a different lesson where you learn about the limit or you use limits to find a derivative, but we're actually going to do a shortcut. So if we look here, we have a function and then the function's derivative. So I'm going to fill it in right here. We have 2x, 3x squared, 4x cubed, and 5x to the fourth. And if you don't already know this pattern, you can pause the video and try and figure out what the pattern to this is. But if you do already know it, the power rule, we have a generic form, right? F of x equals x to the power of n. F prime of x is nx to the n minus 1. So what does that mean, right? This number up here, we're going to multiply it by whatever's in front, and then the power we decrease by 1. So if we look over here, right, we had this 2, we bring it to the front, and then we make the 2 minus 1, so we get 2x. Right? 3, we bring it to the front, we get 3x, and then we decrease this, so the 3 becomes a 2. And it is familiar over here, right? We have the power rule for logs, right? We learned that in the past. If I have log of x to the 2, I can rewrite that as 2 log x. Right, so this is expanding logs. So let me put expanding logs. So this you learn in pre-calculus. So this is sort of something familiar, right? Similar. So we're just pulling stuff in the front, but this one's a little different because we also changed the degree up there. Okay, so let's look at some easy examples. We have y equals x to the 37th. So this one, we're going to use this notation, dy over dx equals, we pull it to the front, 37x, and then we minus 1. So 37 minus 1 is 36. Over here, we're going to write it in the other notation, y prime equals, pull it to the front, 9x to the 8th. All right? So this is pronounced y prime. Right? So it's not, if you're trying to read it to someone or read it aloud, it's called y prime. And this one you could just say dy dx. Okay, they mean the same thing. They both mean the derivative, right? So instead of using this complicated equation up here, we're just going to do the power rule, and it's much quicker. Okay, let's look at some examples that are not as easy, but hopefully you get the gist. Okay, so the first thing that we want to do is we want to rewrite it in a form that's easy to take the power rule of, right? So we're going to use our exponent laws or exponent rules, right? I'm going to put that here. We'll need to use exponent rules, laws, to put it into a form that is easy to use the power rule on, right? So we want to rewrite it so that it's easier, right? So we can rewrite this actually as y equals x to the negative 1. This is a power rule, right? If it's to the negative power, it's actually in the bottom of a fraction. But this looks a lot more similar to this base right here, right? This right here. So it's easier to use the power rule. So now that we're in a nicer form, we can differentiate it. Take the derivative. So you have dy over dx equals, we pull to the front, negative 1 times x to the negative 2. And the reason why that this is negative 2 and not 0 is because, right, we have, I'm going to put over here, right, negative 1 minus 1 equals negative 2, right? If I owe someone $1 and then I owe them another $1, now I owe them $2. So negative 1 minus 1 is negative 2. And let's just simplify this to make it look better. We have a negative 1 on top, and then we have x squared on the bottom. So this, right, it's sort of like this is the form we got. We had to rewrite it to make it prettier. to make it easier to differentiate, we differentiated it, and now we put it back into our pretty form. Okay, right here, we have something similar. We have y equals x to the negative 4. We're going to take the derivative. Let's use y prime this time. Y prime equals negative 4. We pull that in front x, and then we minus 1. So negative 4 minus 1 is negative 5. Right, I'll put that over here. Negative 4 minus 1 equals negative 5. And then we're going to rewrite it so it looks nice. Y prime equals negative 4 on top, x to the 5th on the bottom. Okay, now we're getting into roots. We need to use our exponent laws with roots. So anything to the square root is the same thing as y equals x to the 1/2. And now we're going to differentiate. So we take y prime, we pull the 1/2 in front, x. 1/2 minus 1 is negative 1/2. And we'll do the math down here, right? 1/2 minus 1 is the same thing as 1/2 minus 2 over 2 equals negative 1 over 2. Right, so adding and subtracting fractions does not go away in calculus. You'll have to be pretty comfortable with it, right? And remember, when we add and subtract fractions, we need a common denominator. Okay, so we're going to rewrite this. Y prime equals 1 over 2, and then this is square root of x. So normally we want to rationalize the denominator, but we're just sort of going to leave it here. But if you wanted to, you could rationalize the denominator, and you could do y prime equals 1 over 2 root x times root x over root x equals root x over 2x. So you could write it like that, but we're just going to leave it like this for now. But if I had asked to write it with the denominator rationalized, then you could give me this answer instead. All right, this one's a lot trickier, but I believe in you. So we have y equals x to the 3/7. So if you're ever confused on what the rule is, right, this stays the same, and then this is the fraction. So when it's just this, right, this is the same thing as 2. It's just 1 over 2. Or if we had if we had the cube root of x, that would be x to the 1/3, because this is like a 1 right there. So it's sort of something that you just have to memorize, but if you can remember this right here, then you should be able to transfer that rule and try and figure out when it's like uglier like this, when we have a different root and we have an exponent inside the root. Okay, so we have y equals x to the 3/7. We're going to differentiate it. So you have y prime equals, we pull it to the front, 3/7x. And then 3/7 minus 1 is negative 4/7, right? 3/7 minus, I'm just going to make the common denominator right away, negative 4/7. And then finally we make it pretty. So this one's a little trickier, right? We have a 3 on top, we have a 7 on bottom, and then we have 7th root of x to the 4th. Another way that you could write this is you could write it as y prime equals 3/7 7th root x, and that whole thing is to the 4th. Right, these are the same thing, that's equivalent. So you can either take the root and then you do the power, or you could do the power and then take the root. That actually doesn't matter which order. All right, let's go to the back side. Some tricky examples. Okay, so we want to simplify it first and then take the derivative. So the key is to always get it in a format that's easy to take the derivative. Right, so that's essentially like we have x to some sort of mystery power here, right? And then we can take the derivative. So this we have a fraction, so we need to make it look in the format that we want, right? And this just takes a lot of practice, so it's okay if it's sort of confusing at first. So we know that f of x, this is the same thing as x to the 1st over x to the 1/2. And remember, when you have a fraction, right, these are more exponent laws. If you have an exponent over an exponent, that's the same thing as doing x1 minus, or x to the 1 minus 1/2, right? So we keep the x there and we do the exponents, so that gives us x to the 1/2. So this one we've already taken the derivative of, right? F prime of x equals 1/2 x to the negative 1/2. So we get 1 over 2 root x. So we found the derivative, and then the final step is we plug in that number. So we're going to do f prime of 7 equals 1 over 2 root 7. And again, you can rationalize the denominator, right? Or you could leave it like that. If you wanted to, you could do root 7 over 14. In this case, it doesn't matter. I'll be more specific if it does matter. So we found the derivative at 7, right? So this is saying f prime at 7, this finds the slope of the tangent line Okay, so what does that mean? Let's sort of take a look on a graph to get an idea. Okay, so we have x divided by the square root of x. Let's take a look at that graph. Okay, so we have this graph right here, and then at 7 we see, right, if we were to draw a tangent line, right, let's just sketch it right here, right? If we were to draw a tangent line, it would be something like that, right? And so what the derivative is finding for us, it's finding the slope at that line. So if I look, right, 1 divided by 2 root 7, that is 0.2. So if we look at this graph, at 7, this slope right here is 0.2. So, right, the line of the slope is 0.2. M equals 0.2. And this is 7 right here. So that is the whole point of the derivative. It's finding the slope of the tangent line. Okay, let's look at this one. So we have f of x equals x to the 1/3 times x to the 3rd. We're just rewriting that. And we know that when we multiply exponents, we can actually add that. So that's the same thing as x to the 1/3 plus 3. And so when we're adding fractions, right, we need a common denominator. So 1 over 3 plus 9 over 3 equals 10 over 3. So we get x to the 10 over 3. Now we get to take the derivative. We pull it in front, 10 over 3. X minus 1 would be 7 over 3, right? Because 10 over 3 minus 3 over 3 equals 7 over 3. And then we just get to plug in 8. So we have f prime of 8, because, right, that's what it's asking for. Right? You don't want to just stop here. Like on the back page, we just stopped at the derivative, right? We don't want to stop there because it's asking us to do another step. Okay, so f prime of 8. So you could do it a few ways. Okay, so I'm going to show you 3 ways. If you have a calculator, you can just plug that straight into the calculator and try and figure out that value. You could also rewrite it in the nicer format. So we have 7th root of 8. Oh, sorry, that's 3rd root. The cubed root of x of 8 to the 7th, which is actually a really big number. Or you could do, put it over here, 10 over 8, 3 root 8, and that to the 7th power. Remember on the back how I said you could do either order, right? You could do the root first and then do the exponent, the power, or you could do the power and then the root. So this is actually going to be much more complicated than this, because if you know off the top of your head, the cube root of 8 equals 2. So then you just have to do 2 to the power of 7 times 10 over 8, rather than doing 8 to the power of 7, right? But regardless, you have a calculator. So if you use your calculator, right, we could do, let's do the first one. We have 10 divided by 8 times 8 to the power of 7 divided by 3. We get 160. Okay, I was actually wondering, I got something wrong. This isn't an 8, this is a 3. I was getting confused, right? So this is a 3. I just wrote an 8 here, and I think I just wrote an 8 there. Okay, so let's fix this. 10 divided by 3 times 8 to the power of 7 divided by 3. We get 426. Let's turn that into a fraction. we get 1/280 divided by 3. If we did over here this method, right? So we'd get 10/8 times 2 to the 7th. 2 to the 7th, you can actually do that in your head. So 2 times 2 is 4, 8, 16, 32, 64, 128. So that's the same thing as 10/8 times 128, and that's 1/280 divided by, shoot, this is a 3 again. 3/3/3/3, right? So you can use a calculator or you could do it mentally. Okay, so sorry with the errors there, but the whole point is you take the derivative, you put in the number that they ask for. And so this is the slope of the tangent line when x equals 8. All right. Parallel tangent lines. Let f of x equals x to the 4th and g of x equals x to the 3rd. At what values of x do the graphs of f and g have parallel tangent lines? So if they're parallel, right, parallel means same slope. So we need to make sure that the slopes are the same. To take the slope, we need the derivative. So it's pretty much saying, when is f of x equal to g of x? So, or f prime of x equal to g prime of x. So f prime of x is going to be 4x to the 3rd equals 3x squared. And how do we solve this? So what you'll want to do is move it all over to one side and factor. So we have 4x cubed minus 3x squared equals 0. We pull out the greatest common factor, which is x squared. 4x minus 3 equals 0. We set both of these equal to 0. Right? This is using the zero product property. So we get x equals 0, and we get x equals 3/4. Okay, and let's take a look at the graph to see why that is. So we have x to the power of 4. We have x to the power of 3. We have these two graphs, right? So let's zoom in. Whoops. Zoom in. Let's see if we can zoom in again. Okay, so if we look at this graph, we can see at 0, they both have a slope of like this flat line, right? Right? And so we're not trying to find where they intersect. You know, this happens to intersect. We're not trying to find when the blue and red intersect. We're trying to find when the slopes are the same. So if I was to look at this, let's see if I could draw on the calculator. Right? If I was to look at 3/4, which is the other solution, right? It would be like right about here. Right? And so if we look here, we have this line. It has a slope of like that. And then the red line has a slope similar, right? It's like that, right? So those two slopes are parallel. And so that's what it's asking. It's not asking when the graphs themselves are the same. It's asking when the slopes are the same, when the derivative is the same. So that's why we take the derivative first and then find where they equal each other. All right, so power rule is super, super important in calc. So I would highly recommend looking through the practice problems and checking the answers and seeing if you got them right.